In this video, we're going to use the periodic properties of the trigonometric functions to find exact values of certain angles. Remind you, of course, you should know your 30-60 right triangles, or how to generate them, the 45-45 right triangle. So you're able to find the trig function values of angles like 60, 30, 45, or any angle that has a reference angle of 30, 60, 45. And then the periodic properties, we can make this statement: if f is a trigonometric function with period p and k is an integer, then f of theta plus any integer times the period will equal to the functional value of the angle theta. So adding, k could be a negative or a positive integer, so this tells you that adding or subtracting a period corresponding to the function you're working with gives you back the same function. So f of theta plus a multiple of the period gives you back the functional value of that angle. So let's look at these problems. So I'm just going to rewrite this as a sine. I'll put this as pi plus 16 pi over 4. And we'll do these without using a calculator in this case. So this then will be the sine. Let me just divide this out. This will be pi over 4. And then divide 4 into 16 pi. This is 4 pi. And of course the period of the sine function is 2 pi. So here you do have a multiple of the period. 2 times 2 pi is 4 pi. So this should be the same thing then as the sine of pi over 4. And you can think of that as 45 degrees if you don't like to work with radians. That's pi over 4 is 45 degrees. That's 180 over 4. So the sine of 45 degrees using your right triangles, the 45 right triangles I just went over, is 1 over the square root of 2. Or hopefully you have it memorized that that's just the square root of 2 over 2. And that's your exact value. The next one, we could say that's the cosine. Cosine of 10 pi would be the same thing as the cosine of 2 pi plus 8 pi. And the period for cosine is also 2 pi. So this 8 pi is a multiple of the period. That's 2 times 4 pi. So this can be written as the same thing as the cosine of 2 pi. And you can think of that as 360. The terminal side of that angle is going to be on the x-axis. We can find a point 1, 0 on that terminal side. So using the idea of points on the terminal side of an angle, the cosine would be the x, which is 1, over the r, the distance from the origin to the point. It's like a unit circle. It's 1 over 1, so this is 1. Okay, the next one, tangent of 390. That'll be the same thing. So now we're doing degrees. I can write this as the tangent of 30 degrees plus 360 degrees. And the period of the tangent function is pi, or 180. So the 360 is a multiple of that, 2 times 180. So I can say this is the same thing as the tangent of 30 degrees. Notice, it works the same way. If you just say, well, 390, I want to reduce that. I want to keep it positive, but I want to reduce it. I can subtract a multiple. So I can say, well, subtract a multiple of the period. So I can subtract 180 and then subtract 180 again. And of course, it gives me 30 degrees. And then again, I use the 30-60 right triangle and write out that the tangent of 30 degrees is 1 over the square root of 3. Hopefully, you just have those memorized. Rationalize this by multiplying by the square root of 3 and the square root of 3. Numerator and denominator, this will give me the square root of 3 over 3. Next one, have the sine of 540. Now this one I do a little bit different here. I just say, well, the sine of 540, and sine has a period of 360. So I'm just going to subtract 360 from that. And that should give me the same value. Shouldn't change it. So if I subtract 360 from 540, I get 180. So if you don't know the answer to that one without a calculator, you can look at it this way. 180 is this angle here. If you can find any point on the terminal side of the angle, you can find the trig value. This point, if I go just 1 over, that'll be -1 and 0. And the radius of that unit circle would be 1. So the sine of 180 would just be 0 over negative 0. Then the next one, the secant of 510. Secant has a period of 360 if you're working with degrees, or 2 pi if you're working with radians. So in this case, I'm just going to subtract 360. Another way to do it, instead of breaking it up the way I was doing it, just subtract 360 from that. It shouldn't change the value of your answer, so this would just give me 150. Again, that angle then would terminate somewhere over here. Here's where we can use a reference angle. That's 150, so this angle right in here should be 30 degrees. So we should know then that the secant of 150 should be the same as the secant of the reference angle, which is, in this case, is 30 degrees, except for the sine. So this should be positive or negative, so this is where you have to know, okay, in quadrant 2, the x component is negative and the y component is positive. And the cosine of an angle in that quadrant is given by the x value over the r value. Well, r is the radius of the circle from the point to the origin. And remember, r is always positive. This is for the cosine. And of course, the secant and cosine are reciprocals, so it's pretty much the same except it's a reciprocal. So for the secant, it's r over x. R positive, in this case, because of where we're at, the x is negative. So this answer has to be negative. I'll put a negative right there. And then you can use your 30-60 right triangle. And this should come out to a negative 2. The answer to this part right here is just 2 over square root of 3. And then we just rationalize by multiplying the numerator and denominator by the square root of 3. So this will give me minus 2, square root of 3. And square root of 3 times the square root of 3 is square root of 9, so this will just be 3. So the answer to this one comes out negative 2 multiplied by the square root of 3 divided by 3. Thanks for watching. We'll see you next time.